Okay, so we are going to talk about inequalities involving two triangles. So we've done inequalities with one triangle where we look at the angle measures and then we decide whether or not the side should be larger or not. Now we're going to do that with two triangles. Okay, so a triangle has to be set up a certain way for this to work. Focus up here, please. Okay, so the first way is side angle side inequality. When you hear side angle side, what do you think of?
Two sides and an angle.
Two sides and an angle. Exactly. Where does the angle have to be?
In the middle.
It has to be in between the two sides. So what this is telling us is if we have two triangles here, and if we know that two sides of a triangle are congruent, so let's say those two sides are congruent. Okay, and then we know something about the angle in the middle. They are. I just mark them as being congruent. They may not look it, but they are. Yes, I did. They're congruent. Those two are congruent.
Oh, sorry. I went on the same triangle.
Yep, on two different triangles. And then if we know something about the angles, so if we know this angle is 50 degrees and that angle is 60 degrees, we can compare the two sides. So let's call this side A and let's call that side B. Which side do you think is going to be bigger, B or A?
60.
I'd say
B.
The 60 is going to be bigger because the angle is bigger. So you can write an inequality between these two.
A
So-
is greater than B.
Well, didn't you just tell me B was bigger though?
A
So
is
A
less
is
than B.
less than B.
My bad.
So that would be our inequality.
That's it? That's all.
Okay?
Why don't we just keep doing easy? I feel like there's a catch. Are we going to do something extremely hard at the end
Yes, exactly.
No.
yes.
There will be, it will be in diagrams, so you'll have to kind of delve and dig, but right now we just broke it down to its simplest form. No, we'll do some. We won't do some proofs today, no.
What, today?
Proofs.
No. Do we still have...
I hate proofs.
Don't you guys worry. We've got it. Just don't worry about it yet. We're not there yet.
You told me we're done with proofs.
We're done with two column proofs, yeah.
Now we're doing like...
No, the indirect ones. You guys remember those?
No, I really don't.
Okay. They're much easier. We'll be doing those next week.
Proofs suck.
It'll be okay.
I'm taking your word for it.
Okay, Tyler, how old are you?
Was he doing this thing again? No, he was doing it all day yesterday. Miss Ryman looked at him and got scared.
Let's just focus on the next one now.
Alright, next one.
Next one, you guys. Focus on the next one. You are in high school. Okay, so side, side, side.
Right? That's what you're eating.
Close. But side, 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 you do think of three sides, right?
Yeah.
Okay. So now, for side, 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 it's the same type of idea where we have two sides are congruent. Okay? But then we know something about the third side. So let's say we know that this side is 8 and that side is 12.
So,
What can you tell me about the angles, do you think?
B is bigger.
B is bigger. Why would B be bigger?
Because it's 12.
line 12.
Because the side opposite is 12. So we would say angle A is, which sign would we put? Less than angle B. Okay? Exactly. Same thing, just looking at it the opposite way.
What do you mean? Oh, I see.
So here we looked at the angles to compare the sides. Here we looked at the side to compare the angles. The only way you can do this, though, is if you have two sides being congruent in the two triangles like we have, and we are looking at the angle that's in between those two sides and the side opposite. It's the only way we can do it. Okay? So we could not compare angle D and C here. Those two would have no comparison to one another because we don't have the two sides congruent around it. Okay, so you have to have the two sides congruent around it in order to be able to do the comparing.
So,
Okay?
let's see, so if they give us
Do
like
people
a
actually
full
watch
triangle and numbered, and they give us like this side and this side, would we do this angle here?
You would,
Side, side, side.
yeah, you would do, it's always the angle opposite of the side. So like if we were given here that these two sides were 5 and those two sides were 7, okay, you could then also compare A and B. Because you see that, you physically see that those two are congruent instead of having the congruent marks. Okay, so now let's try some examples with this. And yes, people do watch this.
How do they make so many
Okay.
Like, you just go into different computers to make it have more views?
No.
Like how many doorknobs need keys in
Go.
the world, and each key is different?
Yes. Okay.
How does that work?
But
Okay.
what's like your most viewed video?
Like this.
Focus on what we are doing. Focus. So we want to write an inequality using this diagram. So this is what I'm saying. The diagrams are going to be a little bit more complicated than just two triangles written out separately. So we have to look at the diagram and kind of depict the diagram, decipher what's really happening there, and figure out. So look at the diagram. You're looking for two sides to be congruent. Okay, so that's what we need to find. So on the diagram, do you guys see any sides that should be congruent?
Yeah.
What do you see?
Side SR and side SP.
Okay, so SR and SPR, they're both marked as 12. Is there another side that should be congruent?
Can something be congruent? I think you labeled one of those.
Yes, something can be congruent to itself. So SQ here is congruent to itself. Because it's... Right, because they're sharing the same line, so they have to be equal to each other. Okay? So now, let's look. So we know, what are the other two side lengths that we know?
T, we don't, there's no magical T on there.
We know 14 and we know 15, don't we?
Yeah, you labeled that number one, compare angle QST.
QSR, there you go. Okay, so now take a look at the diagram. The two sides that we have are 14 and 15. So which one is less than the other?
Wait, what is that?
These are our other two sides, 14 and 15. Okay, so here 14 should be less than 15, correct? That's because 14 is less than 15, so then you look at the angle opposite and you write down that equation. So what's the angle opposite of 14? Yeah, so you'd say 5x minus 14 is less than our 46. And now we solve that. Okay? So here we are going to compare QSR and QSP. So QSR was our 46. So here is our QSR. We'd put our less than sign in there, and QSP. So here would be the comparison between them two with the inequality. And then, to find the range of values containing x, we would just need to solve that inequality. So 5x minus 14 is less than 46. How would we solve that? Add the 14. So 5x is less than 60. Divide by 5. Not 30.
20.
15, yep. So x is less than 15. Now, we do want to also think about other things that we know about angles. Angle measures. Would we ever have a negative angle measure?
No.
But if I say x is less than 15, could x then also be like negative 20 here?
No.
Yeah, negative 20 is less than 15. If I plug negative 20 in for my x here, am I going to get a negative angle? Yeah. So when we have angle measures, we always have to make a second equation to make sure that the angle stays positive. So whatever equation we have here, so here we have 5x minus 14. We want it to be positive, so we're going to say it should be greater than 0, because if it's greater than 0, it's going to be a positive number. So now we're going to solve this equation as well. So add 14. So we have 5x is greater than 14. Divide by 5, so it's x greater than. How many times does 5 go into 14?
3.5.
2.8 or 2 4/5.
That was close.
So now here are our two numbers that we got. And then just like yesterday, we're going to combine these two numbers together and write it as one inequality. So how would we combine the 2.8 and the 15?
How can x be bigger if x is not a variable?
Yeah, so 2.8 is less than x is less than 15. What was your question, Tyler?
How can x be less than?
60 divided by 12 equals.
Stop. Let me ask my
Doesn't
question.
equal 15.
It does. What does it
60
equal?
divided by 5 equals 12.
You're right. It does.
I have a question.
Good catch, Rhett.
How can x be less than because it's a variable?
What do you mean? Yeah, 12 is
Sounds like this.
12 is right.
Then you have 10x.
How can? What do you mean?
How can x be less than 3.8 if x is a variable?
Well, that just tells you the values that x can be. So here this is saying x has to be less than 12. So some number less than 12. But over here it's saying it's got to be greater than 2.8. So it's got to be some number in between 12.8 or 2.8 and 12. So any number in between there works. So that's what, so yesterday you guys did, you got the two numbers and you wrote it as compound. Okay, so that's, we're taking from yesterday. Why did we use 0? We use 0 because we want to be greater than 0. Yeah, because we don't want our angle measure to be negative, we want it to be positive.
Do you have a band-aid?
No.
All
right.
I can push the string all the way through it.
No, let's focus on this. Next example. Not right now.
My knee's bleeding.
Not right now. Compare.
Bleed to death.
Measure of angle LDM and the measure of angle MDN. So the first thing we do when we have this is we want to find two sides that are the same. Okay, so we need to find two sides that are the same or are equal to each other. So on this diagram, where are our sides that are the same?
Well, I would say
Okay, so we got 12 and 12,
MD is congruent to itself.
and then they're both sharing MD, so we can say MD. So now what is our third side for those two triangles?
16.
Okay, so here we have 16 and then we have 18. So that means we can compare those two angles.
See, why even put that bottom triangle in there? Because that's just complicating to people.
Well, it's so that you can look at the diagram and figure out what you have to be looking at. Yep, so you'd say 9a plus 15 is less than 141. And so up here, what would be the relationship between LDM and MDN? So LDM would be talking about 18. MDN would be the 16. Yep, so we fill that in with a greater than sign. Okay, so now we have to solve this to find our values that A can be. So what would we do to solve? Yep, subtract 15. So 9A is less than, I just didn't hear you, 126. Divide by 9. So A has to be less than 14. What's the second equation that we're going to have to make here? 9A plus 15 should be what? Greater than 0. It's always greater than 0. Not add 15. Subtract 15. we can't have a negative degrees, but certainly there are some values for a here that are negative that would still give us a positive degree measure. So we have 9a is greater than negative 15. And then what?
0 would be a good one.
Divided by 9.
12. 12 is the answer for everything.
So 1 2/3 instead of 1.6 repeated.
12 in yellow.
So pretty much.
You could put 1.6 with the repeater sign.
So pretty much anything from negative 14 up to infinity would give us a positive angle.
Anything from negative 1 2/3 through infinity would give us a positive measurement here.
Yeah.
But we want it to fall in between those two values. So now what would be the compound inequality that I would write that would have those two values?
Wait. Negative 1.6 is not X.
Oh my goodness.
Hey. I'll use my name.
So negative 1 2/3 is less than x is less than 14.
Should we pull this out?
Is this making sense?
So do you always use the number 15 on the other side, then greater than 0?
You're always going to use your bigger number on the right-hand side and your smaller number on the left for your compound.
Same as yesterday.
Yep, so same as how you put it together yesterday. All right, let's look at another one. Write an inequality relating the given pair of angles or segment measures. So here we're going to compare AB and CD. So we just want to compare them. So in order to do that, we have to make sure we have two sides that are equal. So where are our two sides that are equal here?
CB and DA.
Okay, so CB and DA are both 15. And then the DB, which, because it's with itself. So now, do we have side measures this time?
Yeah.
For the missing side, no, but we have angle measures. So we have 50 and we have 20.
Go.
So we go across. Which one should be the bigger one then?
I would say B.
The one across from B. So what side is across from B? CD. So we'd see CD is greater than AB.
Will it always be like that where it's like the two sides and then the middle one is
YOLO.
Yeah, a lot of the diagrams will be like that where you have the one side is shared between the two triangles. Yes, you get a book assignment. I don't hate you. All right, we're going to do one more example.
I wish Luke keep talking to give me 100%.
All right. Write an inequality to describe x. So here we need to find sides that are congruent. So what do you notice on our diagram?
They're all congruent. This is one that
Okay, so we have some that are already congruent. So here we have those two are, and we have the angle in between them and the side opposite. And over here, which angle do we have? 60, so we're going to look at the side opposite of that one.
Can you start writing this?
So how can you relate those two together?
160 is greater than 40.
Okay, so 60 is greater than 45, so how would we write the equation with our x's in there?
12.
So which,
X plus 5 is greater than 3x plus minus 5.
yep, so we'd say x plus 5 is greater than 3x minus 7. So now how are we going to solve this for x?
Subtract X.
Good, subtract x. And then what?
Add 7.
And add the 7. So what do we have here?
13.
Not 13.
14. 12.
12 is greater than
2x.
2x. And how do we get our x? Divide by 2. So 6 is greater than x.
So you can put those around.
Yeah, we can certainly rewrite it as x is less than 6. Now, here we have side measures. Can side measures be negative?
No.
No, they cannot. So we need to also make these greater than 0. But we don't need to make both of them greater than 0 because they already have a relationship. We know x plus 5 is already greater than 3x minus 7. So which side here would be the smaller side no matter what?
7. 6.
Well, x plus 5 is greater than 3x minus 7. So the 3x minus 7 here, this would be the smaller side. Okay, so we just need to make sure that the smaller side is positive. So our second equation would say 3x minus 7 is greater than 0. Okay, so we don't need to do it to both. We just need to make sure that our smaller side would be positive.
3x minus 7.
Well, it's smaller because it's across from the 45, which is less than the 50. So how would we solve this?
Positive 7.
Add the 7. So 3x is greater than 7. And then what? Divide by 3. Well, what's 7 divided by 3?
2.3.
So 2 1/3. So then how do we write those two as compound? So 2 1/3 is less than x, which is less than 6. Okay?
I understand what we're doing.